In this video, we'll discuss graphing quadratics using the rate of change pattern. Hopefully we remember that lines have a constant rate of change. As x increases by 1, the y will increase or decrease by the same amount every single time. But in a quadratic, the rate of change is not constant, which is what causes the curve. So looking at the parent function, please note that the scale is going by 2. I've put those major points in there on red. And from 0 to 1, so as x increases by 1, the y went up 1 unit. But now as x increases from 1 to 2, it was at 1, now it's at 4, it has increased by 3 units. As x increases from 2 to 3, so from this point up here, that y value increases from 4 to 9, so that has gone up by 5 units. And the next point from there would go up 7 units and 9 units and so forth. It keeps increasing by 2 every time. Pretty much it's like all the odd numbers. So in a parent function, as x increases by 1, the y starts increasing by 1, then 3, then 5, and continues to follow that pattern from there on out. So now let's look at another graph. This is y equals 3x squared. In this case, you can see it's narrower than the parent function because of that 3. And because of that, we can't look at too many points on here. But from 0 to 1, this one has increased the y value by 3 units. And from 1 to 2, it's increased from a value of 3 to a value of 12, which is 9 units. So if in the parent function, the pattern was 1, 3, 5, and so forth, if we look at what's happening here, now it was 3, then 9, and that is all we had from the graph. But notice the a value is 3. It pretty much took that normal pattern and multiplied each of them by 3. So if we wanted to find the next point in the parabola, we would have to start at this point and go up 15 more spaces. So what's nice about this is that if we know the vertex of a graph, we can use that pattern to help us quickly find some other points. So let's look at this equation. First, we need to find the vertex. To do that, we look at the h value and the k value. And the vertex here would be 5, 7. So I'm going to do 5, 1, 2, 3, 4, 5, 6, 7. Here's our vertex. A lot of times you'll be asked to graph the axis of symmetry, which is just that vertical line through the vertex. In this case, the axis of symmetry is x equals 5. And now we can use that pattern to find some other points. So normally the pattern would be 1, 3, 5, 7, and so forth. But here our a value is -3. So I'm going to take each of those and multiply it by -3. So starting from the first point, we'll start by going down 3, and then down 9, and I don't think we'll have enough space, but we would go down 15. So here's my vertex. I'm going to go down 3 and 1 to the right. Here's another point. And then I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 over to the right, and there's another point. And the next one would be to go down 15, so that is not going to fit on my graph. And now the nice thing about the axis of symmetry is it does mirror the parabola on both sides. So I know if my first point was right here, then that means I can reflect it across to the other side. And then if my other point was right here, I can reflect it across to that side. And then I would just connect it. It's not going to be perfect, but do your best and connect your points with your parabola. Make sure you put arrows at the ends. So once again, the normal pattern is as x increases by 1, the y increases by 1, then 3, then 5, then 7, and so forth. But if you have a different a value, you can just take those numbers, multiply it by the a, and that'll tell you how many spaces that you need to count. Now I will say it is not great for all equations. It works in most cases, but it's not great for all of them. Because if we look at this one here, there is no h or k value, so our vertex will be at 0. And I know my normal pattern is 1, 3, 5, and so forth. Okay, but here if I multiply each by a third, I would have go up a third, go up 1, go up 5/3 right away. You know, I'm not going to have an exact point there. So that's not going to kind of be that helpful because I don't really exactly know where my points are going to be. Here, going up from here 1, so I guess like 1 1/3. It's doable, but if you need very precise points, this is not the best way to do it. And you should probably just, you know, take some values, plug it into the equation, and find some points that way. So that was how to graph quadratics using that rate of change pattern, which is as x increases by 1, the y first jumps up by 1, then by 3, then by 5, and then every odd number after that.